All right, so let's get started with the first level of the challenge. You can find all of the information about the PsiChiR challenge at their Open Science Framework repository, but I've pulled all of the data and the code books into folders here in your files pane of your project. So if you go into the scripts folder down here, all of my code solutions are in this folder if you really get stuck and just want to look at the answers. But if you open the code templates, you'll see here that there's a .rmd file called March 2020 template. If you open that one, you can see that what I've done here, I'm going to make my console smaller. What I've done here is put notes that are in the white sections of this document and gray chunks that we'll write our code in. And this is how Markdown documents work. So our Markdown is a special format of our file where you can write notes to yourself interspersed with chunks of code. And when you knit the document using this little knit button that has a ball of wool and some needles at the top, it will knit the document into a HTML format that is really easy to share with other people. So this is a template document that I've created that leaves the code chunks blank, and we'll fill them in as we go. But just to see what a Markdown document looks like in its knitted form, let's go ahead and press this knit button right now. And it should work that it gives you this nicely formatted document, leaving out all the code chunks for the moment, right? And so if you have a look at this, you can see that the text that appears in the white chunks, this is just normally formatted text, but you can create headings using hash. So if you use one hash, you'll get a big heading. If you use two hashes, you'll get a smaller heading, three even smaller. All right, so what we're going to do is start by loading packages. Now, in this project, I've already installed all the packages that you'll need to do the analysis, so you don't need to worry about that. But each time you want to do an analysis in R, you need to load the packages that you'll need to use. So you do that using the library function. And in this first gray chunk, we're just going to load all of the packages that we'll need for all of the levels of the challenge simply by typing library. And the first package we're going to use is the tidyverse. Now, the tidyverse is a monster package that is a package full of other packages. And all of the packages within the tidyverse allow you to do data wrangling and visualization using a similar grammar that is relatively easy for beginners to get their head around. So I call library tidyverse at the top of every analysis document that I'm going to use, because inevitably I will need functions out of library tidyverse, even just to get data in. The next package we're going to use is the here package. Now, here is really useful because one of the hardest things about working with data in R is getting your head around file paths. So R really cares where your data is, and it's not necessarily intuitive to tell R where your data lives if you don't use the here package. Now, here allows you to define where your data is relative to the top level of your project folder. And it gets around some of the challenges of telling R where data is in Markdown documents versus scripts, and makes, for beginners, it much easier to define file paths. The next package we want to load is Janitor. Janitor is a great package for cleaning data, and I use a function called clean names in every time I read data in. And what clean names does is just make all of your variable names lowercase with underscores in the gaps, so that the formatting is consistent. And then we're going to want to load the PsiChiR package. The PsiChiR package is a really nice package for those of you who are psychologists, because it allows you to write APA formatted documents. But for this purpose, we're just going to use one function out of it that allows you to format a ggplot using APA style. And then the last package is the JMV package. Now, I really like the JMV package because it is essentially a series of wrappers for simple statistical functions. It comes from the people who wrote Jamovi, which is a point and click alternative to SPSS that is run on with R in the back end. But the JMV package that you can use within R makes it really easy to do simple statistics like t-tests and correlations and ANOVAs, and makes the format of the output that it gives you much easier for beginners. So those are the packages we're going to use today, and you just load each one by calling library and then the name of the package. And we can run this chunk of code by pressing the little green arrow on the side. All right, so now we have loaded our packages. The first thing we need to do before we can do any of these levels of the PsiChiR challenge is to read the data in. And we're going to read the data in using the read_CSV file, which is from the tidyverse reader package. And so what we want to do is create a new thing, a new data set, a new data frame in our environment. And so we want to decide what we're going to call that. Let's call it March for the moment. And we use this assignment to say we want to create a new object called March, and the output of all the code we wrote on the right-hand side is going to be assigned to this object called March. And then we want to tell R where our data is. So you can see over here, I've created a folder called data, and there's a CSV file in this folder called March.csv. And so we want to use that read_CSV function to read in this March CSV. But we need to tell R where it is. And so we do that using the here function. And so we're going to go open bracket and then here, and then we're going to tell R where this data is relative to the top level of our project file. So you can see here, RStudio Cloud kindly gives you levels of file path, kind of like a file path in this top level header here. So we can tell R that our data lives within a folder called data, and then the file is called March, making sure we remember to do a capital M. The matching is very important. So we can tell R that our data lives within the data folder, and it's called March.csv. So we're going to run the read CSV function, reading in the data that's located here, and assign it to a new object and environment called March. And in theory, if we press this green arrow, it's going to create a new data frame in our environment over here. Ta-da! All right, so this looks like an error message. It's really just feedback. I wish it wasn't red, because I have this aversion to things that are red. I automatically think that something is wrong, but it's not. So in this case, it's just telling us that it's done what we asked it to do. We have, it's pulled in the data. These are the names of the variables. It's telling us what kind of data is in each of these variables. Most of them are characters. And it has created this new thing in our environment over here. Now we can see that the format of these variable names is not terrible, but I, as a general rule, like to keep variable names lowercase with underscores in any gaps. And so what I tend to do when I'm reading data in is to just add on the end of the piece of code that reads my data a clean names function. So this is what I was talking about from the janitor package. If you use this pipe to string levels of functions together, RStudio will run several steps on your data all at once. So this pipe is a really important concept to get your head around. It's tidyverse specific. So people who learn base R and then try to move to tidyverse have a really hard time getting their head around what this pipe thing does. I think beginners who have never learned base, it's really intuitive. What you need to remember is that when you're adding a pipe, you're essentially asking R to do and then. So what I'm asking R to do here is use the read CSV function to read the data that lives here in my data folder, and it's called march.csv, and then run clean names on it and assign the output of these two functions to this thing called March, right? So if we look at, before we run this new chunk that we've added the clean names to, let's open this March data. And you can see here that for the moment, all of the variable names have capitals in them. They're not terribly formatted, but sometimes, particularly when you're reading things from Excel, the variable names are really awful. And so you want to make them more consistent. So you can look at your data in a kind of spreadsheet type format just by clicking on it in your environment. But if we try this again, let's just run this again with the clean names and then open it from our environment again. And you can see how everything has been made lowercase and there are now underscores in every gap, right? So that's what the clean names function does. It's super useful, particularly when you're given a data set that the person who created it in Excel didn't think very hard about how they were naming each of the variables. And the way you name your variables in R is important because you have to type them every time you want to refer to them. And so it makes your life easier if by default they are all lowercase and have underscores in the gaps. All right, so the next thing that we probably need to do before we get on to the first level of the challenge is to just minimize this data set down to what we actually need, right? So you can see over here that we've got 247 observations. So there were 247 participants, I assume, and we've got 80 variables. The challenge doesn't require you to work with all 80 of those variables. And so just to make your life easier, let's create a smaller data frame that contains just the variables that we're going to need. And we'll do that using the select function from the dplyr package. So the select function, the dplyr is one of the packages that is within the tidyverse, and the select function allows you to name just the variables that you want. So what we're going to do is select just the variables that we're going to need. And I'm going to make a new thing. What am I going to call it? Maybe March small. So again, I'm making a new thing in my environment, and I'm using this assignment to say that, all right, assign the output of all the code I write on the right to the new object that we're creating on the left. And so what I'm going to do is going to take this March data frame that I've just read in, and I'm going to use this pipe. So I want to pipe it into a select function. And then I'm going to select just the variables that I need. So up here I've said we only need to interact with GPA, scores for male, female, people of color, white, and gender of the participant, and select just those variables plus age and ethnicity. All right, so the nice thing about this is that, you know what I'm going to do first? I'm going to do a little trick. So what you can do is use the names function to get a list of all the names that are in your data frame, or the names of the variables. And when you want to run just a line of code, you can use the shortcut Command Enter to run just that line. Right? I'm going to make my console smaller. You can see these are the names of the 80 variables. And so I actually only want to select age, gender, ethnicity, GPA, male score, female score, POC score, white score, I think. Is that all the list? All right, so what we're going to do is say, take our March data and pipe it into a select, and we'll just select age, ethnicity, GPA, white score. Now, sometimes RStudio is really helpful, and it will, if you start writing the name of a variable, it will autofill it. So I want white score and POC score and male score and female score and gender. So GPA, male, female, POC, white, gender, age, and ethnicity. I think that's all the variables we need. So I'm going to run this line of code using Command Enter. You can see what I've done here is created a new object in my environment called March Small that now only has 8 of those 80 variables. And if we open that, you can see that that is much, much easier to deal with. It even fits within the screen. All right, so I'm going to stop there for the moment. And in the next video, we'll learn how to sort data, which is the first level of the challenge.